Hello class 10 students, I hope everyone is doing well. So, lesson number 3 আমি discuss কৰিছিলো resistance of a system of resistors, that is resistors in series and parallel, right? So, based on the topic, আমি কিছুমান numerical solve কৰিছিলো. So, I hope তোমালোকে practice কৰি আছা. So, আজি lesson number 4ত আমি firstতে কিছুমান numerical solve কৰিম আৰু তাৰ পিছত এটা topic discuss কৰিম. So, topicটো হৈছে heating effect of electric current. Okay guys, now let's solve some numericals. So basically আমি ইয়াত দুটা formula use কৰিম, that is Ohm's law V equal to IR and resistance R equal to rho into L by A. So we know that area equal to pi R square. Okay, now let's see question number 1A. How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohm? Now question number B says, how much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 ohm? So students, question duita similar, current potential difference dia hoy ase duitate aru resistance dia hoy ase. So we have to find the current, okay? So current uliabo lagibo. Etia soa first circuit for question number 1A. So electric bulb resistance to hoise 1200 ohm aru potential difference to hoise 220 volt. It is for second circuit or resistance to hoise R2 equal to 100 ohm and potential difference is same, that is V2 equal to 220 volt. Okay. So guys, we are given V1 is 220 volt, R1 is 1200 ohm and V2 equal to 220 volt and R2 equal to 100 ohm. So we have to find current I1 and I2. So here we will use the formula Ohm's law, that is V equal to IR. Easy one, right? So now see the solution for V1 equal to I1 into R1. So we know that V1 is 220 volt. So we have to find I1 and R1 is 1200 ohm. So by rearranging it, I1 equal to 220 upon 1200. So by cancelling it, we will get current I1 equal to 0.18 ampere. So guys, malke jiman para calculation to nije koribole try kora, okay? Even though I am helping you out, but you should try by yourself also. Now see here for solution for B, V2 equal to I2 R2. We know that V2 is 220 volt and R2 is 100, right? So I2 equal to 220 upon 100. We will get I2 equal to 2.2 ampere. So here current through the bulb is 0.18 ampere, okay? And the current through heater is 2.2 ampere. Clear everyone? Now moving to question number 2, the potential difference between the terminals of an electric heater is 60 volt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 volt? So basically question to duta part dia hoy ase. First part to dia hoy ase potential difference to 60 volt, okay? Aru current to dia hoy ase 4 ampere. So it is second part to hudise amak current to kiman hobo jodi potential difference to bahi 120 volt hoy jay. 60 pra 120 volt hole current to kiman hobo. So basically we have to find the current. Okay, I hope you understood the question. So we are given potential difference is 60 volt, right? And current is 4 ampere. And another potential is given, that is increased potential difference. So we will mark it as VI. VI is 120 volt. So we have to find the current I. So here we will use the formula, that is V equal to IR. Okay, now see the solution here. So from here we will find the value of R, okay? And resistance we will get R equal to 15 ohm. So see here, when V is increased to 120 volt, then so এতিয়া V2 যদি 120 volt হলে increase হয়, তেতিয়া কি হ'ব? So V2 increase হলে R2 একে থাকিব. That means যদি potential difference increase হয় but resistance to same থাকিব, constant থাকিব, okay? So we will get I equal to VI by R. So this VI means increased potential difference. So increased potential difference to হৈছে 120 আৰু resistance আমি পালো 15, right? Now by doing the calculation, we will get current I equal to 8 ampere. So the current in the heater is 8 ampere. Clear everyone? So potential difference to 120 volt increase hoar pisot current to hobo 8 ampere. Now see the next question number 3. Resistance of a metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature? So, edal metal wire length dia hoise 1 meter aru he wire dalar diameter to hoise 0.3 millimeter. Aru he metal wire dalar resistance dia hoise 26 ohm. Okay? Now see the solution. Now we know that R equal to 26 ohm, L equal to 1 meter and D equal to 0.3 millimeter. So ita diameter to ami radius hole nibole hole ami pam R equal to 0.15 mm. Right? We have to divide by 2. Then we will get this R. Etia so unit to dia hoise millimeter. So ami ita millimeter to ami meter le nibo laibo, right? So we have to multiply it with 10 to the power minus 5. So we will get R equal to 15 into 10 to the power minus 5 meter. Okay? Now we know that R equal to rho into L by A. Therefore, resistivity equal to R into A by L. So iti ami jano je area equal to pi R square. Right? So now by putting the value of R, that is 26 ohm, aru ami pi value to jano 3.14. Aru R square value to is 15 into 10 to the power minus 5. And length is 1 meter. Okay, now calculating it, we will get resistivity equal to 1.84 into 10 to the power minus ohm meter. Therefore, resistivity of metal equal to 1.84 into 10 to the power minus 6 ohm meter. So guys, this question was not that difficult. Just tomaloke sabo laibo code ki change koribo laibo. Suppose here diameter to dia hoise, so we have to convert it into radius. Okay, our unit pur saba jodi millimeter thake, we have to change it into meter. So these are the few things you need to remember. So students, etia ami discuss korim effects of electric current. So electric current or ki effects ase. So the first effect is heating, second effect is magnetic, and third effect is chemical. So now first let's discuss the heating effects of electric current. Now see here, electrical appliances such as television, iron bulb, etc. becomes warm if used continuously for longer period of time, right? So this is known as the heating effect of electric current. Now see here, in a conductor, the atoms they are in the state of vibration and free electrons they are in the state of random motion. Okay? Etia ami kinetic energy to janu je eta energy jetia eta object motion ot thake. Okay? So yet motion ot ase electrons aru atoms pur. So we can say that there is a kinetic energy. So yat thoka junbur electrons, he electrons bur atoms aru positive ions bur logot jetia collide hoy, when there is a collision between electrons and atoms with some other positive ions, then there is a loss in kinetic energy. Okay? But according to law of conservation of energy, energy cannot be destroyed, hence this loss in kinetic energy is converted into heat energy. So law of conservation of energy mote energy to destroy koribo nwari. Okay? So junto loss wa kinetic energy, he energy to convert hoy heat energy le. Okay? Okay, next we discuss korim Joule's law. So see here, heat produced in a resistor is directly proportional to square of the current, resistance of the conductor, and the time for which the current flows. So swa conductor tat jetia heat produce hoy, he heat to directly proportional to the square of electric current. Okay? So he conductor to jiman electric current flow hoy, tar square to directly proportional hobo. Okay? So kar logot directly proportional? So heator logot directly proportional. Am I clear? So etia next to swa conductor thoka resistance or logoto heat to directly proportional. Okay? And last one is heat is also directly proportional to the time for which the current flows. So etia electric current flow hobole time eta to lagibo, right? So conductor tat electric current flow hobole jiman time lagibo, he time to logot heat to directly proportional. I hope everybody understood Joule's law. Okay, now let's see the mathematical relation. Okay, so consider a current I flowing through a resistor and let T be the time during which a charge Q flows across. Okay, so according to column, we know that current I equal to charge by time. So therefore we can write it like this: right? Charge Q equal to I into T and mark it as equation 1. Now next, see here, consider a current I flowing through a resistor of resistance R, okay, through a potential difference V. So according to Ohm's law, we know that V equal to IR and mark it as equation 2. Now see here, the work done W, as you can see here, in moving the charge Q through a potential difference V, okay, so it is V into Q. So according to volt, we know that V equal to W by Q. Therefore, we can write it like this, right? Work done equal to V into Q. So mark it as equation 3. Now substituting equation 1 and 2 in equation 3, we get, so it ami tinta equation palu, right? So it ami equation 1 aru 2 substitute kori equation 3 place korim, okay? That means we will put the values of Q and V in equation 3. So by putting the values of V and Q in equation 3, we get work done equal to I square into R into T, okay, and the unit is joule. So this work done, it will transfer into heat, that is heat equal to I square into R into T joule. So guys, I hope everybody is clear now. So this is known as Joule's law of heating. Okay, now let's test your brain. So see the first question, which out of these is the right answer for Joule's law? So definitely correct answer to ulai ase, right? That is option C. But wait. So C is not only the correct option, but A and D are also correct option. So see how. Eti ami janu je V equal to I into R, right? So 8 ki dia ase H equal to V into I into T joule, right? So eti ami a V value to jodi IR place koru, then we will get H equal to I square into RT joule, okay? So that is the Joule's law, right? So option A is also correct. And option C, as you can see here, it is already given, it is correct. Now see here for option D how it is correct. So it is given V square into T upon R, okay? So it ami V square place at ami I square into R square put koribo parune, because we know that V equal to I into R. So by putting the value of I square into R square into T upon R, by cancelling this to R, we will get H equal to I square into R into T joule, okay? So option A, C and D are correct. So next, soa light produce koribor karone electric heating use hoy, as in an electric bulb. Etia bulbot thoka juntu filament, he filamentor material to hoise tungsten. So filament made of tungsten. Etia tungstenor characteristics hoise, basically tungsten to a strong metal with a high resistance and high melting point. So melting point around 3380 degrees Celsius, okay? So this strong metal tungsten, it is used for making bulb filaments, and the filament, it should be thermally isolated as much as possible by an insulating support, okay? Now see, the bulbs are chemically filled with inactive nitrogen and argon gases to prevent oxidation. So basically bulbs are bhitorot chemically inactive nitrogen aru argon gases thake, okay, to prevent oxidation. That means to prolong the life of filament. Etia soa filament to jiman power consume kore, the most of the power consumed by the filament, it appears as heat, okay? But a small part of it is in the form of light radiated. Alright, next see electric iron. So basically electric iron to logot ami sobe familiar, but a structure to bhalke najanu, right? So now let us see the structure of electric iron. So electric iron down portion of the coil of high resistance thake, okay? So a taller portion to eta coil thake, he coil to resistance besi, okay? It has high resistance, and this coil, it is covered by an insulated mica sheet. It is a bad conductor of electricity and good conductor of heat. So etia a coiler uporot eta insulated mica sheet cover hoi thake, okay? So etia he mica sheet to it is a bad conductor of electricity. That means electricity par hobo nware, okay? But it is a good conductor of heat. Now see here, this insulated mica sheet, it prevents the current from entering into the metal and thus protecting the user from getting an electric shock. So ami janu je metal to hoise eta good conductor of electricity. So etia a insulated mica sheet to nothoka hole current to flow hoy user গাত electric shock লাগিল হয় okay so this insulated mica sheet it just protect the user from getting an electric shock এতিয়া এই কইলৰ তলত এটা heavy metal block থাকে okay একদম down portionত now see here when electric current passes through the coil it gets heated so basically যেতিয়া এই ironটোত electric current pass হয় তেতিয়া হে কইলটো গৰম হৈ যায় okay and thus the metal block it becomes heat and we can use the iron for press our clothes clear everyone so now see here another common application of Joule's heating is the fuse okay and basically it is used in electric circuits now see here an electric fuse protects circuits and appliances by stopping the flow of excess current so ketiaba unduly jetia high electric current flow hoy tetia fuse to a circuit aru appliances pur protect kore clear everyone so now see here this is the structure of an electric fuse and it has a porcelain body this portion is called porcelain body okay and it has a wire of lead and tin so this electric fuse it consists of a piece of wire which is made of lead and tin so it electric fuse to kot thake basically fuse to device or logot series connection hoy thake as you can see here the electric fuse is placed in series with the device okay now see domestic voltage in our house is around 220 volt to 240 volt etia ma ghoror jontu voltage ba domestic voltage tar range to hoise 220 to 240 volt so a range of bhitor thakile there is no harm in the electric fuse clear everyone but when there is short circuit so short circuit hoise jetia eta large amount of current flow hoy take short circuit koy okay tar mane specified value ke jetia current to flow hoy through the circuit tetia he fuse thoka juntu wire he wire dalo temperature to bahi jay aru temperature to increase hoa loge loge he fuse thoka wire to melt hoy jay okay and it does breaks the circuit clear everyone and these are the rates of electric fuses used for domestic purposes okay now see one question why are coils of electric toasters and electric irons made of an alloy rather than a pure metal or nichrome wire is used for making the heating elements of electrical appliances like iron geyser etc give reasons okay so both are similar questions so eta ama khudise যেহেতু এতিয়া ইলেক্ট্ৰিক টোস্টাৰ্স আৰু ইলেক্ট্ৰিক আয়ৰণত থকা যোনটো কইল হে কইলটো আমি পিওৰ মেটেল ইউজ নকৰো ৰাইট ৰাদাৰ উই ইউজ এন এলয় সো এতিয়া হে কইলটো কিয় পিওৰ মেটেলে নবনায় এলয়টোৱে বনায় ওকে সো উই হ্যাভ টু আনসার দ্যাট সো এতিয়া নেক্সট কোৱেশ্চনটো ধৰিছে নিক্ৰম ৱায়াৰটো ইউজ হয় ফৰ মেকিং দ্য হিটিং এলিমেন্টস অফ ইলেক্ট্ৰিকেল এপ্লায়েন্সেস লাইক আয়ৰন গিজাৰ এটসেট্ৰা why we use the nichrome wire okay guys so see the answer coils of electric toasters and irons are made of alloys rather than pure metals because resistivity of alloy is higher than pure metals so alloys into resistivity hey resistivity to pure metals otke besi okay it is higher than the pure metals now see the second point alloys have higher melting point and so they don't melt easily so normally pure metals or melting point to alloys bilakor logot comparatively kom okay and thus alloys have high melting point and so they don't melt easily so alloys bilakor jehetu high melting point ase he karne hetu easily melt hoy na jay okay but pure metal hua hole easily melt hoy gol hoy now see the third point alloys do not oxidize at high temperature and thus can be kept red hot so normally pure metal were easily oxidize ho jay kintu alloys were high temperature oxidize no hoy and thus it can be kept red hot all right now moving to the last question of this lecture why does the cord of an electric heater not glow while the heating element does so heating element to glow kore but electric heater jundal cord he cord dal glow no kore why so see the answer the heating element is made of alloy which has very high resistance so when current flows through the element it becomes very hot and glows so heating element to alloy di bonwa hoy thake ami janu je alloy resistance bahut beshi it has very high resistance so jetia current to flow hoy through the element he element to gorom hoy jay and thus it glows okay now see the second point The cord is usually made of materials like copper and so has low resistance. Thus, for the same current, the cord does not become so hot and hence does not close. So, এতিয়া electric heater যোনডাল cord, সেই কৰ্ডডালৰ মেটেৰিয়েলটো normally copper, okay? আৰু আমি জানো যে copper resistance বহুত কম. It has very low resistance. আৰু যেতিয়া সেই same current flow হয় কৰ্ডডালেদি, তেতিয়া সেই কৰ্ডডাল গৰম হৈ নাযায় আৰু গৰম নোহোৱা কাৰণে glow নকৰে. I hope everybody understood. So guys, we are almost about to complete this chapter. So there is only one more lecture left, okay? So if you have any doubt, you can comment. Thank you.